Hello, everyone. We're just going to wait a minute or two here just to let everybody get logged on, and then I'll start.
We see people logging in right now. You should be able to hear Jeff and myself and see the screen. If you're having any issues with any of that, you can type in the public chat down at the bottom right-hand corner of your screen. If you have any issues during, any technical issues, definitely let us know. We can attempt to help you out. Jeff won't be seeing the chat. It's a little bit distracting. So if you have questions, please type them down in the bottom, and Marissa and I here will make sure they get over to Jeff. We're happy to take questions throughout. We're also going to have a Q&A time at the end. Feel free to ask Jeff anything about the presentation or anything else you're interested in. How many kids he has, if he's nervous, those types of things.
A little nervous. We should be good, though.
We'll be great, Jeff. I think we've got a full house here if you want to get started, Jeff.
Yep, sounds good. All right. Good morning, afternoon, and night to all that have joined. I appreciate everyone that has logged on today. It's going to be a lot of fun. Just a quick housekeeping item. As Melinda mentioned, if you want to post any questions in the chat, feel free. I should be able to cover most of everything that might come up. But however, there's always a few questions that kind of throw me for a loop. So feel free to throw those in there. I can guarantee you that this will be a lot more fun than the safety dance song, but it's going to be tough to beat. Let's get physical. So without further ado, let's get technical on how to design, install, and keep your Splashpad running. So this is our design and spec team. You are all familiar, if you've logged on to our previous sessions, you're familiar with Melinda, Jennifer, Marissa as design spec managers. Jen is our client services representative, and myself being the technical specialist on the team. Today's presentation is going to focus on 4 key areas. First and foremost, the considerations when selecting features for the Splashpad. Obviously, we need to get water to the design. How do we size this water flow? What system is right for your application? Next, we have additional components to complement the system. How do we want, or do we actually require UV? And how about holding tanks and size and all those peripheral items? And then lastly, we're going to discuss, now that everything's selected, we want to just discuss the best practices regarding pipe installation and what we see in the field, and a few hilarious what not to do's. All right, so you've decided you want to soak kids with water. Well, how much water do you want? How much money are you working with? These are the 2 biggest factors at the early stages. If you have a 1-inch supply line, it doesn't really matter how big your wallet is. You can only spray a garden hose amount of water. If you've got an unlimited budget, what are you doing talking to me? Go talk to the people that built the Bellagio. But we're talking Splashpads, so shall we get going? As a general rule of thumb, here are the rough flow rates for what we would consider kind of standard sizes for a Splashpad. So we've got 1 inch at 20 gallons a minute, 2 inch at 70, 4 inch, basically going to supply the ocean to a Splashpad. These numbers are basically based off of never exceeding 8 feet per second of flow rate within the pipe. Once you exceed this number, water hammer can be a real issue that can start to affect pumps, manifolds, and other systems within the park. So we just want to make sure that we're keeping it below that. But in reality, a 4-inch line, you'll be able to accommodate most any park a municipality is going to dream up. However, when we do start to get into the 3-inch and 4-inch territory, we need to ask ourselves, do we really want to take all this water away from the fishes? This is where the budget starts to rear its ugly head. Do you want to afford the water cost long-term, or pay up front for a system to mitigate the water usage and keep the environment as happy as a clam? When we start to look at a considerable amount of water, we also need to consider the other end of the system, the drainage. Many times the sewer cost can be as much, if not more, than the cost of water. In some cases, I've seen 3 times as much. All right, we've got to do a little math. Don't worry, I've done the calculator bit for you. All you need to do is put on your readers and follow along. Let's take a 3-inch supply line, for example. Let's run this at 150 gallons a minute, 7 hours a day, 5 days a week for 4 months. Obviously, a park could be open longer and more days than listed, but Mother Nature always likes to get in the way and put a damper on the fun times with some cold, rainy days, so we take that into account. So based on these numbers, the park would use 63,000 gallons a day, 315,000 gallons a week, 1.26 million gallons a month, and 5.04 million gallons a season. That's roughly 7.5 Olympic-sized pools per summer. Now, I don't want to scare anybody away from using a flow-through system. They absolutely have their place in the cosmos, but we need to be smart about where they are applied. Now, before we get too deep into the reads, let's do a quick recap of what a flow-through system is. Don't worry if you don't know some of the terms I'm referencing. All will become clear as we continue. A flow-through system is as basic as a splashpad gets. A city supplies water to a manifold. Preferably, a controller tells the manifold when to do its job. The water is then sprayed and goes down the drains and out to sanitary. Some places with a water shortage are very concerned with this water loss. So with that said, you'd think there's a better way, no? Well, there is. Water treatment systems. Now, don't worry, I'm not going to start spouting off, pun intended, a bunch of terms without giving some context. So here's a little snippet of a system I drew up for a current project I'm working on. Feel free to take a screenshot for reference, because this will be the last time you ever see this slide. So obviously we have drains. Here's our manifold. We've got a diverter, a holding tank, chemical tanks, 2 of them in this case. We've got 2 filters, and a water treatment system skid and a UV system. Now, these systems aren't going to always look exactly like this. This is a Waterplay design system. So we do incorporate our pumps, our chemical controllers, our splashpad controllers, pressure sustaining valves, all those sorts of features on the skid itself to make it a little bit more of an easy drop-in system. However, they can be a wide range of looks and feels. So this is just kind of an overview of our offering. Now that we've gone over the components of the system, let's discuss exactly what a water treatment or recirculation system is. The 2 terms are interchangeable. These systems are a great way to collect water in a holding tank, treat it via a chemical process, and respray it for hours of nonstop fun for less daily water cost. This is usually very important to the kids. I'm told often by my 4-year-old, "Dad, I don't want to go to the water park today because the water costs too much." No, that never happens. Don't worry. But it can't be that simple, can it? How do you get this black magic at your park, you ask? We need to decide which system is right for you. There are 2 styles of treatment systems, and the selection is based on the area that you live in, usually. You pesky Carolinians, you get double loop systems. For most of the rest of the states anyway, it's a single loop most of the time. There are always exceptions to the rule, and that's why the designer of the system needs to be aware of the code in your area. An initial conversation should be had with your local health authority to ensure a correct system is selected from the start. It makes for a much easier conversation later on when everything is being submitted for review. Making friends with the health authority in your area is a great way to start a successful design and review process. If you make the drawings and system easy to read and complete during the submission process, you'll find the reviewer will be much easier going with questions and comments. If your work is in shambles, the reviewer may make your life harder in return. Another great reference is the Model Aquatic Health Code. Many jurisdictions actually use this health code to draft up their own codes. So be familiar with your local area, be familiar with the MAHC, and you'll have a much more successful project. All right, so system number 1, we've got a single loop system. This is the easiest one to grasp. The overall system is very similar to a double loop that we'll touch on. You have a single tank, a secondary disinfection unit, a manifold, and a diverter. Where this differs is you only have one pump. The system is one big loop of spray, drain, filter, treat, and spray again. This system ensures every ounce of water is sprayed on those smiling kids is actually safe water. If the system becomes out of balance chemically, safety measures should be in place to shut down the system to remove any chance of little water players coming in contact with bad water. And here's your difference: additional pumps. The double loop system has an additional loop that is running nonstop to treat the filtered water, or keep the water filtered and treated, sorry. The biggest downside of a system like this is making sure everything works in unison and you aren't pulling too much water to the features. If the water in the tank starts to drain too quickly and there isn't enough water or contact time between the water and the chemicals, the water isn't considered sufficiently treated and can cause health issues. A well-designed double loop system is just as safe as a single loop. It just takes a little bit more thought when considering flow rates. Now, I don't want to turn this into a sales pitch. I'm not a salesman, and I don't plan on being one ever. I will, however, go in over some areas which we find very important and include in our systems, and something you should look for when researching splash parks and recirculation systems as a whole. The system should be designed to meet or exceed local health codes. This can include the Model Aquatic Health Code. Now, I say meet or exceed. There are some places you can't exceed. Systems that are requiring a wiper system on their UV, such as the Los Angeles County, that's about as tippy top as it can get. We can't exceed that. We can just meet it. So there are a few areas where it's just a meet, not exceed. The priority of the system should be to provide clean, safe water. Using quality equipment and properly sizing tanks and pumps and other vital pieces will ensure this outcome. And being reasonable to maintain. Is the system easy to access? Are parts readily available? Do I need to call 6 different companies to buy parts? Or is a one-stop shop an easier solution? All of these should be considered during the design and purchase of a system. Now, there are a few extra little considerations at the peripheral equipment. Is the equipment of high quality, or are things like flanges and unions that are being used on the system of lesser materials? Are there pressure gauges being used throughout to ensure good flow rate through the system? As a sand filter gets dirtier, the pressure drop between the inlet and the outlet will start to widen. This is an indication that we need to clean the system and do a backwash. Without these gauges, it's a total guess as to when this needs to be backwashed. It's the little things like this that can create headaches for maintenance personnel, and they are absolutely somebody you need to consider when for their needs who are actually going to be using the system. The system can be very safe. It can be very efficient, but if it's a pain in the ass to operate, it may not get maintained or serviced as often. Now, we're all familiar with the system types. How do we go about actually sizing the system to the design? At Waterplay, we have size systems based on part flow rate: 150, 300, and 450 gallon minute units. This allows us to easily reference a system, place it in a design, and have a price available immediately. We know that not all projects are equal, and we don't just throw a system at a project and call it a day. No siree, Bob. Once the project has gone to order, we'll make sure that the pump and the equipment is sized accordingly for elevation changes and other intricacies for the individual project. Now, this all sounds fine and dandy. We got our design, check. Selected the recirculation system, check. Now let's spray some water. Oh, not so fast there, Speed Racer. How are we treating the water? Where is the water draining to? How do we get the water to the glorious features on the splash pad? Well, now see, you are asking the right questions. Let's start with where the water goes. Everyone knows the water goes through a drain, but there's much more underground than most think. In a flow-through system, that water makes a journey through a sanitary line. This is always up to city code, whether it's sanitary or storm. We've seen both cases. This is always up to the city code and is dictated by what the city determines the water to be. So always check your local code on that. In a recirculated system, we really strive to have a middleman to control the direction of the splash pad water and rainwater. As most of us know, rainwater is on the acidic side of the spectrum, and we really don't want to treat that water if we don't have to. What we would like to use is a diverter, preferably an electronically controlled unit, so that we can take a little pressure off the maintenance staff and make it easier for everyone. An electronically controlled diverter uses a valve to open or close different pathways in the casing to direct splash pad water to the holding tank and rainwater to the storm drains. This ensures that the water we want to treat is almost completely already treated splash pad water. This also works for off times. So if the park is shut down at late at night and kids are wandering around the park and they want to pour something down the drain, we don't want to waste chemicals treating whatever ends up down that drain. Same thing with rainwater. All we're doing is capturing that rainwater. We have to put more chemicals into the system to treat that rainwater. And there is also the possibility of overflowing the tank, and all of that treated water is now going out to the sanitary or storm system. So we want to make sure that we're actually capturing only the water that we want to. Now, I did mention holding tanks just now. Well, we got to store the water somewhere, right? This is the solution. A big old underground pool that you'd never want to swim in. It's a pretty dark place in there. All splash pad water is drained into this holding tank and pulled into the splash pad with a connection to the pump inside the building. Physics, am I right? Determining the size of the holding tank is a key factor in the water management equation. Too small a tank, the chemicals don't have time to interact with each water molecule, and therefore there's a chance of bad stuff to be sprayed on smiling faces. The other issue, you can actually run out of water. Holding tanks have a potable connection to autofill the tank back up to where it's to its working level. However, if our flow rate is too much and the holding tank is dropping too fast, the water that's being brought in still needs to be treated. And if this is actually starting to drain too fast, we can actually run out of water, and no more fun. Now, for actually sizing the holding tank itself, our general rule of thumb is 10 times larger than the feature and filter flow rate in the case of a double loop system, just flow rate in general for a single loop. So in a double loop system, feature flow rate would be all on 150 gallons a minute, and your filtration rate, another 150 gallons. So now we're looking at 300 gallons a minute of flow. Minimum tank size should be 3,000 gallons. There's also a per square footage. We can go 1 gallon per square foot. If you've got a 3,500 square foot splash pad, minimum 3,500 gallon tank. I don't prefer to use this measure as much as I like it for flow rate. If for instance, you're building a very large splash pad, but you want to have the feature spread out a little bit more, there's special circumstances where we want to keep the flow rate a little bit low on a large splash pad. The tank could be excessively oversized for the park. So we just want to I like to use the flow rate for that example. We never like to go less than 2,000 gallons. The pipe system itself, from tank to pump, all the filters, everything like that, but even from the manifold out to the features themselves, that takes up a lot of water. So we want to make sure that we've actually got good capacity within the tank to supply all the features and fill up all those pipes. And then we always want to round up on our calculations. So if you've got a 3,500 gallon tank required, don't go to 3,000, go up to 4,000, 5,000, that sort of idea. As per our sales manager, Kevin Spence, the best solution against pollution is dilution. Make your tank as big as reasonably possible, and it'll mitigate any potential problems once the park is up and running. Now, let's talk about your guts. Specifically, your guts on Cryptosporidium. It's not a pretty sight. This little parasite affects your intestinal tract and can even make the most iron stomachs weak in the knees. So how do we deal with this? Chemicals? Sure, they do a good job. Sand filters? Also a good measure. But what happens if one of these little guys was the star of its class and ninjas its way through those defenses? The almighty secondary disinfection man is there to block the baddie. An ultraviolet system is a great addition to any treatment system. Against what people think happens, UV doesn't actually remove the crypto from the water, but instead breaks down the DNA profile and renders the harmful bug totally inept. Yes, there is some cost involved and some maintenance to perform to keep everything in tip-top shape, but this is the best defense against this gut buster. Many areas mandate a UV system is installed, so it's a good idea to just include it on all projects. So we've designed the splash pad, we've sized the system, holding tanks, and selected some secondary UV for good measure. This is starting to sound like the nursery rhyme I just read my daughter last night. Anyone going to help me bake the bread too? But how do we get this? How do we control the amount of water going out to the features? With this rather simple device, a manifold. Waterplay designs these to be space efficient and easy to mount in any surface or extrusion channel. They come in a variety of sizes in standard 6, 9, 12, 15, and 18 valves, but custom can be ordered if needed. Just don't tell production I told you that. They don't like it. But for a manifold to make your park the best it can be, each supply line should have a flow control valve and preferably an electronic solenoid to allow turning the features on and off during a sequence to spice up the splash pad. All right, you're now all experts on everything splash pad. You can be on your way. No, sit down, relax. We need to talk about best practices regarding the installation side and what to look for during design, construction, and operation of the splash pad. Here's a small list of things to consider when designing the area around the splash pad. Do parents have good sight lines through the splash pad, or does the shape prevent an area from being seen? Do people have good seating? Is there a hill to plop the rump on to watch their youngins play around? Or is it just a barren wasteland and nobody wants to actually be there? Are there a bunch of leafy trees in the area that are going to make maintenance a headache? A strainer basket in the drain and or diverter can help with keeping the holding tank clear, or the sewer system clear of all this leafy material. I prefer to use both. If there's an option, absolutely have a strainer basket in either point. But yes, they are obviously a maintenance issue, but they will help the further maintenance and larger maintenance items down the road. Something very few consider, but to me is a huge deal for setting the feature flows properly, is actually correct positioning of the valve cabinet or mechanical room. This doesn't necessarily have to take into account the distance from a mechanical system to tanks and all that. That's a different conversation. But actually the visibility of the room to the splash pad. If the splash pad isn't visible from where the manifold is being stored, you need to get creative with how things are going to be adjusted. We've seen everything from making a small adjustment down in a basement of a mechanical room and having the maintenance guy run upstairs to have a look at the features to see if anything actually changed, to having two people using walkie-talkies to communicate between a room and somebody standing on the splash pad. Now, both of these obviously have their challenges. There's time considerations, but when you even having two people on a walkie-talkie, the guy on the splash pad doesn't necessarily know what the guy in the room is doing and which feature is being changed. So now it's a guessing game. It just takes a long time. Having this organized and figured out beforehand can save a lot of headache for the people that are actually using the system. I do like to tuck the manifold cabinet kind of into a greenery area near the splash pad. This keeps the operator out of the weather, whether it's rain or sun, and the cabinet can be obscured by surrounding trees and bushes. We've also seen these cabinets being wrapped with vinyl wrap, decoration, city purchase graffiti, that sort of idea kind of gets kids involved. It can also be used as a banner for a grand opening, that sort of idea. One area people aren't aware that most splashpad controllers are capable of is sequencing the features. This is a large consideration during the design phase. For instance, our Waterplay controllers have a sequence with 12 steps per activation touch. By default, the steps are programmed to be 25 seconds long, which when you add it all up, gives you 5 minutes of runtime. This step length is adjustable, but we do find that this is a good timing mechanism to get kids engaged, but it also conserves water if they do hit the button and run, which we've all seen kids do. We don't necessarily want the water running for an hour at a time, so that 5 minutes just gives us that nice little buffer. It also allows the user to have total control of each feature when they turn on and off. And if they want this feature, installing individual pipes to the features would be recommended. This gives them the option to turn any or all of the features on or off during any sequence at any point in the sequence. Frequently, we run into the situation where the customer doesn't want to spend extra money on pipes or on extra pipes, so we combine features into the same supply lines. When I do this in designs, I'm always looking to combine similar features. Maybe take 2 or 3 geysers or multiple water rows. You want to avoid combining dissimilar features or features with a wide range of flow rates or pressures. You'll find balancing the system on site will be almost impossible, and the end user will be disappointed with the display. So take, for instance, one of our large mega soaker features. This is an 18-foot tall behemoth of a bucket, dumps a lot of water, requires a lot of water to supply it to. Now you combine it with a little geyser off to the side. That mega soaker requires a lot of water, a lot of pressure to get the water all the way up those pipes. The geyser is going to be the easiest path for the water to go. So we're going to overpower that geyser, and that mega soaker isn't going to get the water sufficient enough to actually perform the way it's supposed to. So we want to take those things into consideration. All right, so now what do you say we build a thing, eh? What are some things to consider during construction? Granted, most of these are going to be laid out during the design stage, but they still need to be executed during the actual build. What is proper slope on a splash pad? Well, ADA states a slope for wheelchair accessibility can't be more than 2%. Hopefully you all listened to Jennifer and Marissa's wonderful presentations on splash pad design and risky play and now understand the importance of inclusivity in all facets. We really want to allow our wheelchair-bound friends to have as much fun as anyone else. So we need to keep the sloping in mind. With that said, we really want to try and stay as close to this 2% slope as possible. Water really doesn't like to run down the slope with less than 1% decline, especially with a textured surface like a brushed concrete can have, grabbing at the water. So let's make sure that we're staying close to that 2%. Now on the slide, I'm showing pipe slope. And I'm sure some of you are asking, why would we slope the pipes? The pump is pushing water through them for us, so why do we have to have the pipe sloped? Well, in some places of the world, we get something called freezing temperatures. For us up here in Canada, we know this better than most, but there are times when the more fortunate people of the world that they don't have to deal with frozen water and they forget it as a thing. When it comes time to winterizing your splash pad, the easiest way to do so is to open a tap and let the water run to the lowest point in the pipes. You'll want to cap off any of these nozzles, any of the ground spray nozzles and any nozzle that's facing vertical, so water and rain, snow, that sort of buildup can't get back into the pipe. But if there is something that does leach into the pipe, then we can just leave that tap open and it can drain out during the winter. Placing a low point in a pit directly under the manifold is typically the easiest spot. This isn't always possible due to site considerations or constraints. So having that conversation during the design phase is important, but it can be something that can be rectified on site as well. Concrete surface texture is another consideration. A high percentage of our splash pads are installed with a medium brush finish concrete. This gives a good foothold for the kids, but it does allow the water to flow through. We don't want too smooth. The kids will slip on it. Too rough, their feet get hurt. Now, we do come up with the situation where a lot of people don't like to have rough concrete on site or concrete at all on site. Whether it's a safety hazard, that sort of idea, or in their minds, whether it's a safety hazard. One thing that kids are very good at is self-regulating. So if they start running around on a splash pad and they go, you know what, this is hard concrete, I know this hurts if I fall, they do tend to slow themselves down. But if the instance does come up that they want to use a different surface, something like LifeFloor, who we are proud to be partnered with at Waterplay here, we need to take into consideration the installation of the LifeFloor itself. So LifeFloor is about 3/8 of an inch thick. Are we going to actually inset that into the concrete to make a nice smooth transition from any walkway onto the splash pad? Or are we going to do more of a retrofit idea where we pour the concrete and then have a transition strip up to the light floor. These need to be considered when we're installing the features in the play phase bases. If we have the play phase base sitting that 3/8 of an inch above grade, then it's going to mesh really nicely with the light floor. If it's too high, too low, then you can have either a tripping hazard or a pooling water situation. So we just want to make sure that we keep that in mind. Now, for a little bit of a fun portion of more fun portion, I think this whole thing has been fun, but here's a few what not to do's. I'm not here to embarrass anybody. I'm not going to mention any park names or people themselves, but why don't we learn from some mistakes and we can have a little bit of a chuckle at the same time while we're doing this. So here's a few examples of some rather poor installation of the features themselves. We've got ground sprays with a massive indent. I mean, maybe they just wanted a bit of a pool in their splash pad. I'm not 100% sure. We've got some really poor concrete around this little froggy guy. He looks like he's really stuck in the mud there. We've got play phase bases. Again, this would be an instance where the play phase base is too low and some really bad concrete work around it. I have no idea what these guys were thinking. This is just a tripping hazard waiting to happen. And then just a little bit of some water treatment system issues here. So we've got pipes that aren't supported. We've got pipes that are actually touching each other. This one was already starting to wear a hole through itself. And we've got fittings that are actually buried in the concrete. So there's no chance of ever replacing this pipe or anything along those lines. This is a first for me, I think. The drain underneath the drain system itself was a complete void. It took them about 55 rocks to actually fill this void and give the drain underground something to actually look at or hold on to. All right, so hopefully your concrete is poured properly. The features are installed, and now you're standing at the edge wondering what's next. How about turning the tap on and getting some water flowing? This is the exciting bit, when all that hard work pays off and you can finally revel in the joy of a splash pad. But wait, why is the splash blaster spraying 50 feet and the straight up is looking more like a bubbling brook? We got to tune the feature flows so they perform like they're supposed to. There are two reasons for this. Aesthetically, we want the splash pad to represent the images that we've been drooling over since the conceptual designs. Secondly, and potentially more importantly, the water may be running too high and therefore using too much water on a daily basis. This is especially important when using a flow-through system. Places like Wisconsin, they have a mandate where it says they're not allowed to spray more than 50,000 gallons of water a day. Now, that seems like a lot of water, and it is, but over the course of a day at 80 gallons a minute, over 8 hours, you're already starting to exceed that level. So we want to make sure that either we can sequence these features back to make sure that we're not spraying that much water, or we really have to monitor the amount of water that we're spraying through the features and they're not overperforming. So when you get your splash pad up and running, our very helpful product support team is only a phone call away. And in the case of a water treatment system, because we do commission each project, they will be beside you to ensure that the project is a spraying success. Turning the valves on the manifold will give you full control over the flow rate to the features and allow fine tuning of the system. Now let's make sure that those features that have been newly installed and spraying perfectly look pristine. You need to think of these features like a car. You can spray them off occasionally and make them look good for a day, or you can hit them with a wash mitt and have them last much longer. I'm looking at you, Melinda. Inevitably, though, calcium and other hard water deposits are going to build up, and they're going to take the shine away from the equipment. This is true even with water treatment systems. The water that we're bringing into the tank as a fill and then treating that water, we're not decalcifying the water. We're just treating it to make sure it's safe. So if you've got hard water, you're still going to spray hard water. We want to make sure that the features still stay nice and clean even during those moments. Waterplay recommends cleaning with a scale removing product like calcitrol and a soft brush in the affected areas. Polishing and waxing afterwards will keep the products looking sharp for years to come. I do recommend doing a polish and wax at the beginning of the season, and then just doing your regular maintenance. If you've got very hard water, you may have to go through with a wash mitt about once a month sort of idea. But I do recommend doing a bit of a daily spray off if possible. I don't know, obviously municipalities don't always have the capabilities of doing that, but having a daily rinse cycle would be a good idea. And then when you go to at the end of the year, you can remove the features, you can give them a wash, put them away, store them, bring them back out, polish and wax again, and they'll be fresh for a new year. Now, as you can see, there are many things to examine while designing a splash pad. All of them are important, but not all of them are necessary. Including a team like our design and specification team can help alleviate a lot of the hurdles you may come across. Feel free to lean on our experts next time you have a splash pad included in your project. Now to the question portion of our presentation.
Thank you, Jeff. Have you considered stand-up comedy? Because those are jokes. And yes, I don't wash my car properly. Why I'm not maintenance on a splash pad. Do we have any questions? I know there's probably a lot of different questions, things you're thinking of. If you don't want to share them in the chat, you can always reach out to the design and spec team. We can put you in touch with Jeff. You know, the beautiful thing about this team is he is dedicated on this team. So when you're working as a designer on something, you can reach right out to Jeff during, you know, the design process, as you're doing planning. He's a wealth of information, and he is definitely a big part of the success of this team and how we, you know, collaborate with the design community. Any questions? We've got a quiet group today.
Yeah, I thought there was going to be, usually the technical portion is when I get hammered with questions. So
exactly. I think you've answered everything, Jeff. You were so thorough.
That's usually never the case. So
I know we have some people there in Kelowna in the classroom. Thank you guys for joining us for this. We've got several different designers online. Thank you all for, you know, your time with us, working with us, the specifications. We really love what we do, and Jeff is very good at what he does. So, you know, if you have some technical questions after this, we will make this recording available. We will send that out to everybody. We have a question. Can you set up the questions and answers, Marissa?
What is the smallest pad we've done? I don't know, 150 square feet?
Probably right around there. We did a one very recently where I believe we had to do 3 straight ups so it wouldn't flow off the pad. We've also done some that are more, the beautiful thing is we've done it more as an aesthetic in a town square where there's maybe a couple of luminaries or a couple lighted features that aren't necessarily, you know, a public splash pad, but because our features are designed the way they are and they're safe for kids, they're safe to put their hands in them, they'll use those in public settings because you're always going to see a little kid or a dog or an adult in those public settings. So we've done some small ones like that.
And I think as far as small splash pads go, places like daycares, schools, grounds, those sorts of things, some of the more private areas don't always have the largest budgets, but they want somewhere they can just have the kids go run into the backyard sort of idea. So we're actually, we've got a couple options as far as the small splash pad, kind of a pocket park, we like to call them, where we can actually provide a small kind of a manifold kiosk with an activator button, have a few features on there, and it's quite a bit more economical that way. So we've done some very small parks like that for sure.
Absolutely. Dog parks too, in settings.
Yeah, absolutely. budget cost per feature or square foot. So typically the features themselves are going to obviously have their own cost involved. We can absolutely provide all of the feature costs per project. If we've got a design in mind, we can provide all that information. And then lots of times it really depends on the area that you're living in. So California, installation costs are through the roof. Places like Iowa, not so much. So we can kind of gauge that. But when we're starting to talk flow through systems, we're generally dealing with 40-60 split, where it's 40% cost for the features, 60% for installation, concrete, all that sort of thing, piping systems. When we start getting into your water management system, so all of your pumps and filters and all that sort of stuff, we start getting more into the 20, 30, 70, 80 percentage. So it all depends on that, but it's kind of a rough gauge for what we use.
Well, and doesn't it depend too, Jeff, a lot on the features that are chosen? Because we've come such a far way in developing features, you know, with different action reaction, with handles, with turns, with aqualume, with all different type rotomolded plastic, that can, you know, be more expensive than say a straight pipe, you know. So the cost per feature and adding to the square foot depends a lot on the selection of the features too.
Yeah, absolutely. And the other measure, lots of people like to just try to put the largest splash pad that they can put on it, and then the feature kind of budget dictates what they put on the splash pad. Lots of times we like to actually go the other way. So let's reduce the size of the splash pad, but give them more fun per square foot, depending on your budget as well. So there's a few things that we can do to help you mitigate the kind of overall cost and still give you a really nice fun splash pad at the end of the day. And yes, Melanie, dog parks, the biggest thing to consider with a dog park is we aren't wanting to use a water treatment system. Dogs don't have the bathroom habits that humans do. So we don't want to try and collect that water. We don't want any of the stuff going down the drain and into the holding tank and trying to clean that out and try and put that through the system. So whenever we're dealing with the dog park, we do like to have that as a potable flow through system.
We have a really great dog park on our YouTube channel. If you go to the Waterplay YouTube channel, there's a video on there. It's so much fun to watch them. And I believe there's some of our poppets on there which pop water to the dogs and they try and bite the water. It's a lot of fun. Marissa, you've done some fun dog parks too, and we've done some custom water rows that were smaller for the dogs to go through.
Where they run underneath the arches. So fun. And fire hydrants for them to play on are really popular.
Absolutely. You know, and we all spend a lot of money on our pets, so it's a popular feature.
Oh, looks like that's it.
That's it. Well, reach out. Jeff, I'll let you wrap this one up. Great job.
No, thank you very much. I just want to say once again, I appreciate everybody logging in, listening to this. I hope generally a lot of these technical presentations can be a bit of a dull. So I just wanted to kind of spice it up and make sure that we had fun doing this. So thank you again for everybody attending and have a wonderful day.
Thank you, guys.